Hi, and welcome to Always Eclectic Stacy. This is 5-minute chemistry where you learn chemistry concepts and see examples in 5 minutes or less. Today we're modeling covalent compounds in 3 different ways, and we're learning on nitrogen trihydride. Ready, set, let's go! Hi, today we're going to bond nitrogen trihydride and model it in 3 different ways. So first, remember, you're going to draw your Lewis dot. So we're going to start with nitrogen. Remember, nitrogen's in the 15th column, so it has 5 valence electrons. So 1, 2, 3, 4, 5, which means we have 1 bonded pair, and 3 places where things can go ahead and bond. Then for hydrogen, it's in column 1, and it does make both an ionic compound and a covalent compound, depending on how it's being utilized. So for hydrogen, it has 1 valence electron, which means it's always terminal. It'll never be in the middle. So remember, we have 3 hydrogens, because that's what that 3 there means. We're going to draw it 3 times just to show the total amount of hydrogens we have and what can be bonded with. Now, this one looks simple, and it should be simple. Each hydrogen can bond 1 time. Each nitrogen has 3 places for it to bond, which means if we're drawing our Lewis structure, nitrogen does have to go in the middle. And we're going to go ahead and put a hydrogen on either one of 3 sides of it so that we show. And because this has 1 place to bond and this has 1, 2, 3 places to bond, each hydrogen is going to have 1 single bond, because hydrogen can make no more than 1 bond, and nitrogen needs 3 bonds to have a full octet. Now, hydrogen only needs 2 because it's trying to mimic helium. So hydrogen has 2, 2, 2, yay, all the hydrogens are happy, and nitrogen needs 2, 4, 6, 8 because it is trying to mimic the next largest noble gas, which is neon. So let's try a different way. We did this carbon dioxide, where we're going to go ahead and draw the Lewis structures again. Sorry, Lewis dot, but we're not going to go ahead and make the lines. We're going to go ahead and draw it like this, and we're going to go ahead and circle those 2 that are lined up so we can show which nitrogen and which hydrogen are being shared. And this is another way of modeling. The third way of modeling is building your Bohr models. And remember, way back when we did Bohr models, you do your center, and then you do 1 circle for each period it is. And nitrogen is 2 periods down, so it has 1, 2 circles for orbitals. Each hydrogen is only in the first period, so it's only going to have 1 of these. And I'm ever so brilliant at drawing these. And you're going to draw this overlap here, and that overlap becomes important. I'm just going to draw the overlap first this time because I don't have to worry about it. Now, an important thing to remember with this one is that you do have to put in the center, put a lot of information, but for us today, we're just going to go ahead and put in the element symbol of the element we are showing. So each of these is going to be a hydrogen, and this is going to be a nitrogen. Now, nitrogen does have a full first s orbital, so we're going to put those in, and it does have a bonded pair, so we're going to go ahead and put that bonded pair in, knowing that with these 3 overlaps, 1 electron per nitrogen is going to go in that overlap, because this overlap, this area where the 2 Bohr models overlap, is that new kind of orbital that is being created that forms the bond. And for each hydrogen, they only ever have 1 in the outer shell, so that 1 electron they have is the one that is being shared. So you're going to go ahead and put it in that with nitrogen. And now we can count the electrons in our outermost orbital. Knowing that hydrogen wants 2 because it wants to look like helium, and each hydrogen has 2, 2, 2, so hydrogen's happy. And nitrogen wants 8 in that outermost orbital, so it has 2, 4, 6, 8, and nitrogen is happy. Thank you so much for watching. Always Eclectic Stacy. If you like this video, please do not forget to like and subscribe and check out some of our other content. Have a fabulous day.